Yeah, hello dear students. Today's lesson is using the ninth term, book 8. Objectives. What is the ninth term? Exercise 2.3. So what is the ninth term? It is it's nothing strange. We have made this before. We studied in the last video position to term rules, how we make the position to term rules. This is exactly the same, only you have to replace the term position number with n. That's all. We are not making a new formula. Let us make this example. 5, 7, 9, 11. This is a sequence, okay? Now what is the term to term rule here? Adding 2 always. 5 plus 2, 7, 7 plus 2, 9, 9 plus 2, 11. So the multiple of 2 is 2, 4, 6, 8. Now I have the multiple of 2, which is the term to term rule, and I have the sequence. The difference between them give me the number 3. So the position to term rule is 2, which is the term to term rule, multiplied by positions of the sequences 1, 2, 3, 4, 5, etc., and plus the 3. 3 from where? Is from the difference between the sequence and the multiple. Okay, so what's new? What's new is something that you only have to replace the position here, this one, with n. That's all. No more and no less. Let us make an example to see that. Number 1, exercises 2.3. Number 1a, work out the first 3 terms and the 10th term of the sequences with the given 9th term rule. So he gave you the rule. Here I see that he gave you the rule, only he need you to apply it for the first 3 terms, and the answer is this is the first term, second term, and the third term. 3 first terms, 1, 2, 3, plus 6, 7, 8, 9. What is 7, 8, 9? Are the sequence numbers. Okay, what about the 10th term? The 10th term, only you have to substitute 10 in the place of n. It's going to be 10 plus 6, and that gives you 16. So very easy, only you have to replace the position number in the n and give you the sequence numbers. Okay, for this also the same, only you have to do is to substitute the first 2 or 3 positions, which is 3 multiplied by 1, 3 minus 1, 2, 3 multiplied by 2, 6 minus 1, 5, and 3 multiplied by 3, 9 minus 1, 8. This is the sequence number then. Okay, before we go, I like to make a little bit analysis about this. This is the sequence number. Let us check if really are correct and this number here is correct. Let us take the sequence number, we put it at the top, and then we know that term to term rule is 1, so I write the multiple of 1. Okay, this is how you think in steps. First sequence, then you find the term to term, then you find the multiples, and you put the sequence and the multiples beneath it so that you know what's the difference, because the difference will make this number here, should be this number here. Okay, so let us see. 7 minus 1, 6, 8 minus 2, 6, 9 minus 3, 6. So it's correct, 6, 6, 6. Okay, so 6 is here correct because it gave me the same number in the formula. So these sequences are correct and have nothing to do with the Illuminati. Okay, now number 2, this pattern is made from pink squares. Where are they? Write down the sequence of the pink squares. These are the sequence of the pink squares. How did I know this? Because you add only all the squares together. This is 4 squares, this is 7 squares together, this is 10 squares altogether, and this is 13 squares. You add all the squares and give you the sequence of number. Okay, so this is the sequence. This is A. Only you count all the squares, give you the sequence. And B, write down the term to term rule. We know that from A that this is the sequence number, so from this sequence number I shall distinguish my term to term rule. 4 to 7, how much? 4, 5, 6, 3. 7 to 10, 3. 10 to 13, also 3. So I think term to term rule is add 3. So this is B. Okay, see how the sequence is formed. Where is it? This is our sequence. This is our sequence pattern. Okay, how does it form? As you see, we add only 3. to the original one. This is the original. Only the first one is the original one. We say the first number. We added the 3 to it. Then we have this, and then we added 2 3s. We have this, and we added 3 3s, and we have this. If you count all, the pink one here is the sequence number. The orange and the pink are the sequence number. The orange and the pink is sequence number, and this is sequence number. Only the orange boxes are what? Are the multiples of 3. Multiples of 3. Because this is 3 times 1, 3, 3 times 2, 6, and 3 times 3, 9. Okay? Multiples of 3 are 3, 6, and 9. So how did this pattern develop? We say the sequence is formed by adding the multiples of 3 each time, representing the orange boxes. The orange boxes represent for me the multiples of 3. So by adding the multiples of 3, this is how this pattern developed. Okay? So the orange boxes are the multiples, and orange boxes plus the pink boxes together, they make the sequence number. D, work out position to term rule of this one. Okay, we have this, we know now, and we know this is 3, and we know this is also, we've done this before. The multiple of 3 is 3, 6, 9, 12. 3, 6, and 9. I'm sorry, 12, no place. So the sequence is, 4, 7, 10, 13. We know that. Difference between them will give me position to term rule. 3, which is the term to term rule. Okay. Multiplied by the position. Okay, which positions? Any position. This is position 1, 2, 3, and 4. Plus 1. From where did I get the 1? 4 minus 3, 1. So always the difference between the sequence and the multiple, the sequence and the multiple is 1. So you put 1 here. This is the rule. This is the what? This is the position to rule formula. If I tell you what is the 9th formula, you say 9th formula, 9th term. You write here 9th term equal 3 multiplied by n plus 1. That's all. That is the difference between 9th term and position to term rule. Only you replace this position with n. Okay? Try to make exercise 2.3 number 1 and 3. It's very easy. Okay? For those also that they have not the exercise book 8, they find the questions on this link. You have to click on this link. It will bring you to the questions of your homework. So thank you very much for your attention.